Hi again. So today we're going to solve trig equations by finding useful substitutions, and really the keyword is useful. You have trig identities in the formula sheet that can help you solve equations. And I say useful because you can make a lot of substitutions, but they aren't going to help you. So only certain substitutions will help. And it's not always the same. It's depending on the problem. So you really need to be willing to think, pause, not have answers come to you really quickly necessarily all the time. Remember your new BFF. Sine squared theta plus cosine squared theta equals 1. Your Pythagorean identity. You're on a unit circle. X is cosine, y is sine. Leg squared plus leg squared equals hypotenuse squared. And often that will help you, or some other form of it will help you. So, for example, let's solve 2 cosine squared theta minus 2 sine theta plus 2 equals 0. Make this a little less blurry for you. Okay. What you want to do is think about what can we substitute into this equation to solve for one trig function. We've got cosines and sines, and that's no good. Sine and cosine are the most basic trig functions. It's where we started way back in our SOHCAHTOA days. Cosine squared, squaring a trig function, is newer to us. So we want to come up with a useful substitution, a replacement for cosine squared. Well, we talked the other day about being able to rearrange our Pythagorean identity in different forms to help us out. In this case, I want to get cosine squared alone so that I can have a substitution for it within this equation. So looking at this identity, if I subtract sine squared theta from both sides, then cosine squared theta equals 1 minus sine squared theta. Now I have a substitution of 1 minus sine squared theta for my cosine squared theta in this equation, and now I'm with all sines. I have sine squared, I have sine, and numbers, and then I can solve as usual. So I'm going to kind of make this cleaner for us, rewrite it. 2 times 1 minus sine squared theta, which is cosine squared theta from the original problem, minus 2 sine theta plus 2 equals 0. When we solve any equation, we get rid of parentheses first. Distribute. 2 minus 2 sine squared theta minus 2 sine theta plus 2 equals 0 plus 2. Okay, I'm going to rearrange this to put it in a better order for me. Squared stuff first. Negative 2 sine squared theta minus 2 sine theta. And then combining like terms, 2 plus 2 is 4. All right. Well, I'm hoping this is factorable. I don't know. I certainly do not like having a negative squared term. And I do also notice that 2, or negative 2, will divide into all the parts. So I'm going to factor out a common negative 2. That'll make my squared term positive, and hopefully help me factor. Negative 2 sine theta divided by negative 2 is positive 1 sine theta. Positive 4 divided by negative 2 is negative 2. Okay, so if this is factorable, sine squared theta plus sine theta minus 2, it'd be product sum. I need two numbers that multiply to negative 2 and add up to positive 1. Well, 2 is prime, so I either have, for factors of negative 2, 1 times negative 2, or negative 1 times positive 2. Negative 1 and positive 2 will add up to the positive 1 that I need inside. So I'm going to factor this as sine theta minus 1 times sine theta plus 2 equals 0. Just as if they were x's, y's, or z's, set your factors equal to 0. Well, negative 2 doesn't equal 0. You ignore that. But I have sine theta minus 1 equals 0, and I have sine theta plus 2 equals 0. Here I add 1 to both sides, so sine theta equals 1. And go to your unit circle and think about where my y value is 1. Well, up here at 90, y is 1, and that's the only place on your unit circle. So theta is 90 degrees. Over here I subtract 2, sine theta equals -2. There's no place on my unit circle where sine is -2, and in fact, remember from the other day, I can never have a sine or cosine value greater than 1, because those ratios are opposite over hypotenuse. The hypotenuse has to be the smaller side. If I have 2 over 1, that doesn't make sense. 1 can't be smaller, the hypotenuse can't be smaller than the side opposite it. So your only answer here is 90 degrees. Or if I had asked for Radian's answer, he would have written pi over 2. And that's it. Let's try. So the first problem, we used our Pythagorean identity to help us make a useful substitution. In this problem, I have 2 cosine 2 theta plus 3 cosine theta equals -1. Now, it might not seem so terrible because they're both cosines, but this is a double angle formula. If you look at your formula sheet, or your reference sheet, there are cosine 2a formulas, and those are the substitutions you need to look at. So on your reference sheet, here it is, there are all of these functions of a double angle: sine, cosine, and tangent. Now the bad news about cosine of a double angle are there are 3 choices. And again, this plays into the whole making a useful substitution idea. So I have 3 choices for a substitution for cosine double angle. Well, if I look at the rest of my equation, it has cosine in it. So I want to pick a substitution that only has cosine in it. So going back to my formula sheet, this has cosine and sine. That's no good this time. This has just cosine. This has just sine, so that's no good. So for this particular problem, I'm going to choose 2 cosine squared a minus 1. So I'm going to write it on my paper so it'll help me solve the problem. Okay, so we're using thetas instead of a's. It's just an angle name, it doesn't matter. But I'm going to replace this cosine 2 theta with 2 cosine squared theta minus 1 and copy everything else down. So 2 times cosine 2 theta, replace it, 2 cosine squared theta minus 1, copy the rest down, plus 3 cosine theta equals -1. That's the only new work. Everything else is solving a quadratic equation like you've been solving for a while now. So if you're good at solving quadratics, or you're brave at solving quadratics, you can pause the video now and then try it on your own and then fast forward to my answer. Otherwise, follow the steps with me. Again, let's get rid of parentheses, distribute. 4 cosine squared theta minus 2 plus 3 cosine theta equals -1. I'm going to put things in a good order. So my squared stuff first, 4 cosine squared theta, then my non-squared variable, 3 cosine theta. And because it's quadratic, I know I need to set it equal to 0, so I'm going to add 1 to both sides, and -2 plus 1 is -1 equals 0. Again, I always want to try to factor. In this case, I have product sum again. I would need a product of -4. So that could be 1, -4, -1, 4, or 2 and -2. The sum I need is +3. So this is factorable because -1 and +4 will add up to the +3 sum and multiply to the -4 product. It's not a quick factor because a is 4, not 1. So I do need to split this middle. 4 cosine squared theta plus 4 cosine theta minus 1 cosine theta minus 1 equals 0. Split the middle again. Take out a common factor on the left, which is 4 cosine theta. And you're left with cosine theta plus 1. On the right, take out a common -1. And you're left with cosine theta plus 1. So your factors, your new common factor is cosine theta plus 1. Your other factor is 4 cosine theta minus 1. Again, set your factors equal to 0. cosine theta plus 1 equals 0, 4 cosine theta minus 1 equals 0. For the left factor, subtract 1, cosine theta equals negative 1. That's a unit circle value. So my unit circle, I wonder where my x is negative 1. Well, over here, at 180 degrees, or pi radians, x is negative 1. I'll stick with degrees for now. Just go read your problem always in the beginning and see what kind of answer we want. On the right side, I first add 1 to both sides. So 4 cosine theta is 1, and then divide by 4. Cosine theta is 1/4. This is not a unit circle value. It's not a bad value either. Cosine as a ratio is adjacent over hypotenuse, so this is an okay number. All it means, if it's not on the unit circle and it's not one you know, is you get to use your calculator. So let's review that. You're going to grab a scratch pad. You're going to be sure that you're in degrees mode, and I am. And because I'm looking for the angle measure, let's go back to this for a minute. You're going to find the inverse cosine of 1/4. That'll give you a theta value. So back on my Inspire scratch pad, I push trig, inverse cosine of 1/4. And I get theta is approximately, it's not exact, so use your approximately symbol, 75.5, let's say. So theta is approximately 75.5 degrees. Now, that's one possible answer, and your calculator only gives you one. You need to think about cosine. Cosine is also positive down here in quadrant 4. 75.5 is about here. It came out of my calculator. Oops, 5. I need to think about what its co-terminal angle is, or its equivalent angle is, down in quadrant 4. Well, I'm not quite at 360 degrees. I'm 75.5 degrees short. So do 360 minus 75.5, 284.5. So in this case, solving, I have 3 answers. 180 degrees, right off my unit circle, piece of cake. The others from my calculator, 75.5, and then knowing my unit circle rules to find the final value, 284.5. And that's it. Have a great night.